Well, hi, good morning. Thanks so much for coming and joining me here for another round with this record player. Record players do go around, don't they? And I think what I'm going to do is I'm going to take the platter off this record player for the first time and take a look at what's going on underneath. Now, when I tested the record player, it failed to pick up at the end of the record. Exactly why that is, I don't know. I'm not 100% familiar with these guys, this type of record player. Although I have done a few. It comes up real easy. It's very heavy. This is a very, very heavy cast aluminum platter. Yeah, that's money. And that's another attempt to make this a better record player by making the speed very steady. So, not a lot under there. We have the part of the trigger system is here. See it move? That's the part I was talking about in another earlier video about being so loose. And it's pushed literally by the needle in the groove. And that's pushing a subsequent mechanism down in here, which is the one that is probably causing trouble here. Well, I don't know, feels pretty loose. Okay, don't know why. Don't know what's going on with that. Let's take a look at this. Now, something unusual here. It's quite a buildup. Looks like a buildup, or maybe it's corrosion on here. Let's take a little bit of a closer look at that. So unfortunately I can't get really close right now. I don't have a camera that will do it. Even from that distance. So one of the things I'm noticing here is that instead of there being there's some distinct dimensions here, this one, but this is also conically shaped. You know, it's wider at the bottom than the top. So it must be this fine adjustment is literally just adjusting this up and down a little bit on this. That's a little unusual. What is that stuff? I need a closer look. Let's try this. Does the wheel even get up there? Oh yeah, it's on it right now. So we're on 33 over here on the speed. There's quite a shell on this, hard shell. The rest of it feels quite rubbery, but it's got a very hard shell on it, so I think we're going to have to grind this. Oh, look at that. I think that's where I'm chipping at it. Yeah, grind off the surface here, I think. It's a bit of an unusual look to it. It's got a very, very, very sharp edge here. It's like a... almost looks like they made this out of two materials. There's a different material on the outside here, like a retread tire. On the other hand, that just may be a crack. Oh, there's a split in it. I've never seen something like that before. Look at that. Ooh, ooh. The whole chunk's gonna come out. Never seen that before. Like, this is an unusual material. It's white. I've never seen a white or a cream colored wheel. There's the number right on it. Dual written right on it. Well, we better take it easy with this or we're going to have a big chunk out of it and it'll be no good at all. They're usually in with an E-clip. This one's got a screw on it. But it sure passed the traction test. Here, let me put this camera back down here. Does that even magnify much? Not a lot. I miss my other camera. I have not yet decided what to do with it. My earlier camera, the model down from this one here, I can get a lot closer to things. Okay, so what about this surface? I never really, I don't know what to make of it. Let me just check and see if I happen to have a replacement wheel for that or not. Well, let's see what goodies I've got in here. The Walsco Electronics Phono Drive Kit. I got lots of wheels, but what are the chances I have one like that one? Or one that would work suitably in there. Chances are very, very low, in fact, that I would just have a alternate replacement piece. It has to be close to the same dimension. And it's going to have to be the same. Lots of sameness. That's just not possible. This is not going to work out. The size can be a little different, but not a lot. Yeah, I think even if I find one that's the right size, the chance of it fitting on here properly or being made to fit on their property is pretty small. But I wanted to look. Always fun to look into the box of tricks. It's a mono. Guys, and why is this in here? I noticed this. Oh, ever looked inside a transistor? One like this. There it is. It's way inside there. So most of this shell, it's just air inside. Take a look at that under the microscope, really. But another day. Another day. Okay, so we don't have a replacement. No surprise. I'm going to take this off. Oh, wait a minute, let me think again. I checked this and the traction was good. Doesn't feel good at all like this. So the faster speed, or the slower speed rather, is on the highest spindle. There's the least contact between the spindle and the drive. It's the most slippery drive position. What all that white stuff is there, maybe that's some kind of treatment. Like, you can buy belt treatments and stuff like that. For your automobile belts, maybe there's some kind of treatment somebody put on that. Why only on the top? Why not the whole thing? It's right on the very top here too, so I'm guessing this is a treatment of some sort. Okay, let's see if we can get this off. Is that really a screw? You know what? I'm not sure this is actually a screw here. It just doesn't. Yeah, it's a screw. Washer. Well, this screw can be helpful in what I'm going to try to do next. It's not loose. There is an E-clip involved here. Whoops, a little bit of bad camera work. There's an E-clip under there. Somebody should tell them. They're usually up on top. Well, I have to get this out of the shaft, so I've got to take this clip out here. It's a complicated little piece. Okay, now we're going to have to grind off the surface there. I have to get my grinding stuff ready. Okay, so the next step here is to install a temporary shaft, just a screw, and a nut. Just throw in a locking washer here. Need a screw long enough that it sticks out, like that. What's that? That look like a green? Oh. Where's my green? Yellow will do. Okay. Now, I'll take my ever so trusty Black & Decker drill, which I bought. 1980, so that would be almost 40 years old, versus this one, Black & Decker. See, Black & Decker. This one got it at Christmas. Didn't last 6 months. Well, this one never dies. Okay. In fact, I've gone through at least three battery operated drills, and every time this one's in the background and comes out for for service when the others are letting me down. I just need the key here. Uh-oh, what do you do with the key? Oh no, it's gone and put the key down. Where did I put it? There it is. Oh, lucky I saw that. So, surprisingly enough, the outside diameter of these are not very critical in terms of the speed of operation of the record player. They're not critical at all. You can grind it too small. Been there, done that once. Don't want to do that again. But the object is to grind off, say, 1 millimeter of this surface here, and get down to the softer stuff. Just a little worrisome with that crack that it's going to come out in chunks. And if that happens, that's the end of that. I'll have to get another one from somewhere. Okay. There we go. didn't last long. If there's any roughness, if a chunk comes out of this, the record player is not going to play. Oh, there's definitely that's where the crack is. I can feel it. I think that's where the crack is. Lots more to go yet. The hard shell part comes off really quick. And the rubber itself doesn't grind well, so it's hard to grind it past, grind into the soft stuff. Well, that feels a lot better. There's the crack right there. So more than one crack. Feels strange over here too. I don't know if I'm grinding off a very thin. What would they put a special? Why would they do that? Why would they? Well, I don't think it's going to get any better than it is now. I'm doing this, and there wasn't any real indication it was needed, because the traction, the traction test, when I turn the platter backwards and it locks up, you can feel it pushing on this rubber when you do it. It passed that test quite well. Yeah, green. Okay, plugs out. Yeah, never ever do this with the plug-in. I'm not speaking from experience. Did I just tighten it? Yeah, I did. I just know it'd be a bad thing to have that in there and have the machine come on. So in terms of my other Microsoft camera, the only thing that's wrong with it is the wire is broken just behind the camera head, kind of like just in here. And it really irks me that I haven't even tried to fix it. I took a look at it and thought, no. But I don't find that terribly satisfactory. Okay, let's see if we can put this back together properly. What's this nut doing under there? I didn't even question it. Looks like there's a, this is a shaped screw. It has a collar that this nut is going to tighten up against. Well, that's how I remember it. .33. That looks okay. Well, there isn't an awful lot more we can do. Maybe drip a little bit of oil down into that bearing down there. I need a special oil delivery thing I have to go get for that. It's definitely tough to see where the actual bearing is in there. Easy to put oil in and just put it in a stupid spot and it's not doing anything. Looks like it's way down there. Just put a little bit of oil. That's generally all you need. Okay, couldn't really see for sure what happened there, but I think we're okay. Now we have like in most record players, this top bearing down here is more easily accessible than in this record player. It's down below here. So and it looks like it's sealed. So I'm going to just drop a little oil here and there down there. Just a little bit again. Often you can take these right out, and there's ball bearings in there and grease in there. And sometimes there isn't any ball bearings or grease. Just, yeah, grease sounds good to me. Let's just put a little bit on the shaft here. Okay. Well, now what about this problem of not picking up? This is what we really need to focus on now. So there is a system in here. I think it's the same at a high level as many other record players. It's a velocity sensitive system, and it involves the speed at which the tone arm is traveling. As long as it travels slow, it won't pick up. It's when the tone arm travels more quickly, it will pick up. So believe it or not, at the end of the record, where the grooves spread out and you see the tone arm zoom into the middle, that speed change is what these record players are looking for to trigger the pickup. The pickup mechanism generally doesn't engage till you're about a third of the way across the record. So you can do anything you like here, but if you do a fast movement out here, it'll pick up. And you may have noticed sometimes when if you have a record player and you're fooling around with it, sometimes you're moving this towards the middle. Maybe you want to play the last song, and suddenly the record player decides to pick up. You say, well, I didn't even get it near the end. What happened? It's the speed at which you moved it. Now, how does it tell the speed? It's really a stupid mechanism, really. As this moves across the record, it pushes this bar forward, see? And this bar begins to push another piece forward, two pieces. I don't know how this one's done exactly, but in some record players it's two pieces, one on top of the other, two little metal plates. And this is pushing the bottom plate over, and it's carrying the top plate just because it's there with it. This edge of the top plate, which I believe is this little piece you can see sticking out here, that little metal corner, it seems to be in a stupid place. Let's call that the kicker. So as the record player comes around, it has a kicker. There's the kicker. See that little piece there? Just up on top there, sticking up. So every time this thing rotates once, that little tab comes along and knocks into this metal piece, which is the upper plate. So this pushing the lower plate, and that piece, the upper plate, getting kicked by that little thing coming around. So you get this effect. This plate constantly moving in, carrying the top plate being knocked back every revolution. So the top plate doesn't actually move. Because if you were able to move this bottom one fast enough, this top plate will be carried into a new position, which will beat the kicker and get caught in the cotter. You'll get caught on that thing somehow, and when it gets caught on the turning wheel, it pushes the gear mechanism underneath here, that big plastic geared wheel. I didn't explain something. Can you see? You probably can't. Down in there is the geared plastic wheel, and the gears on that wheel are connecting with these gears. So this thing's driven by that wheel out here, on here, and as this thing turns, this gear is going to try to drive that big plastic wheel we saw underneath. But it can't, because there's a gap in the teeth on this wheel, and that gap is sitting right here, and so the teeth on the platter are connecting with nothing. So the platter goes around totally free. Meanwhile, this kicker thing's happening. So once you get to the center, and this moves rapidly, the lower plate is pushed a bigger distance during one revolution than it would normally, and that positions this top piece to catch. Instead of being kicked back, it's going to catch, and when it catches, it's going to literally shove the plastic wheel a few degrees around, far enough for the gears on the plastic wheel to meet up with the gears on here. And once that happens, then we're going to go through one complete cycle of this plastic wheel, which might be 3 or 4 cycles or 5 cycles of the platter. Eventually the wheel comes all the way around, and the part with the teeth missing shows up here, and as soon as the teeth disengage from the drive, from the platter, that's it, it stops. That's how this works. Kicker, kicking back, long as this is moving slowly, kicks it back out of the way. Move this quicker, kicker gets in the way, catches, moves the plastic wheel far enough that the gears engage. Once the gears engage, round it goes. And then, you have those parts inside the grooves on the plastic wheel moving this and moving everything. Now, okay, so I've explained kind of how it works. Problems that typically happen with this is the two plates are stuck. They're stuck together because something's gotten in between and they aren't able to move freely. Is this that kind of record player? I'm not exactly sure what's going on in this one, or even how to really get in there and examine it. But I'm sure there's lots of information on the internet. For instance, there'll be diagrams, exploded diagrams of this record player, and that we could look at. But before doing all that, can we not just examine its operation as closely as possible? But I'm going to get this camera going here. We're going to look straight down into that spot. Okay. Now, I hope my explanation was good enough. There's the kicker part. Well, it doesn't, like, this is all the way to the middle and it hasn't moved anything. Something's not being reset here. Something's not going back to where it should. So I think it's a different kind of kicker mechanism here. This is spring loaded. It would look like this should be pushing this and causing this to get involved with what's going around here. But the spring has it here. Now that could just be because of the state of the whole machine. So what I'm going to do is I'm going to see the machine's in stop position right now. It's pretty hard to cycle this when the platter's off. I can't drive the big plastic wheel around. I need the platter on to drive the wheel. But let me move the start and stop button here and we'll see what gives. Nothing gives. You know what? I can't do this with the mechanism not operating. What's happened here is the control is now here. It won't come back. I don't want to force anything. Okay, let's drop the platter back on. We don't have to lock it in or anything. we're not going to be able to observe these operations. This is one of the difficult parts of these record players with this kind of velocity sensor. You can't really see it in operation, and it's not really intuitive. Why don't you go down? There we go. Okay, so it's not engaged because you see how smooth it moves. Let's switch cameras now because not a lot to see on that one. So, oh, it is engaged. Should just go back down. Oh my gosh. Just ignore everything I say. If you watched enough of my videos, you know that already. Okay, well. Oh, well, that's interesting. What happened there? It appeared to work. Did it start working? Somehow. Let's go again. Okay, so I'll be the motor. Here's the motor turning the platter. Now, when I push this to start, what I'm doing is I'm manually kicking that piece in to engage it. Oh boy, we're in trouble here. What has happened? Jim, what have you done to this machine? Apparently we've gone. Oh, sounds like a near miss. Oh, got it. Not sure at all what's happening here. What? So I moved this control just now. It felt like it was just, I was moving this piece of plastic and nothing more. It's just as light as could be. Definitely something's not right. Something's not right, and if anything, I've made it worse here. So just to let you know, this is what fun looks like when you're doing this work. This is what you got to keep telling yourself. Whoa, fun. Just like those people in Buffalo used to say, fun. Wow. Why won't you work? So this piece comes across just the way it's supposed to. But, oh, at the last minute it pushed something. Maybe this functions completely different from what I was describing. So there's a little piece here that can be pushed. Let's go back to the upper camera. Little piece here. There it is. There's the two pieces. So this is the lower piece, and this is the upper piece. So when I was kind of showing my hands together like this is what it actually is in this record player. This piece and this piece. Now, it just seems odd that this is constantly over here. You can't possibly push it further, can you? And see how far this will push it. No farther than there. There. But this thing just stays where it is all the time. you can picture the gears underneath the platter right in here, coming right through here. And you can see that if this got into the gear, then it would pull this wheel. And then the wheel would get into the gear, the drive gear. Is this supposed to pop out further? Sure sounds solid to me. Or it's landing. Normally this piece in here would be back, and then slowly it's pushed forward. And each time it comes into range, it's kicked. Let me get a kicker here. Kick. And then a little further, and kick. You're supposed to kick this one back, but not this one. This one, they should slide relative to each other. And then a little further. This can't carry it further. It's in the, you know what, maybe it's because, you know what it is? I know what it is. It's because this thing is sitting in the start position here. I've got this in the start position, so this is forcing things. But it didn't start. He says with an exclamatory tone in his voice. Why wouldn't it start? Because that should come around. Kick that guy. If you, in some record players, you can hear this mechanism operating as a record player comes around. You could hear it because it kicks this little bar back, but it's very, very quiet. Spring loaded, and it's in a position that's really invisible. If I flip this over, we're not going to see even this. What could go wrong with it? Well, what normally happens in these things is the spring comes off and things aren't held where they're supposed to be, but that's not what's happened here. Right? There's a spring there, all right. It just seems to be pulling it the wrong way. You wouldn't expect a spring, actually. I got this wrong. Is this piece here the piece that engages the gear? No, I can't see it. It's got to be this. This is in the right place. Okay, so you know, like a Hail Mary thing is to throw lubrication into here. That's not a smart move. Some of these parts in some record players, these parts in particular, never to be lubricated. It's supposed to just be loosely fitted, dry metal. And loosely fitted, it can slide over itself easily. I'm not getting anywhere here. I gotta figure out how this, not really how it works, how it doesn't work. How can this not be working? Somehow. Okay. Gotta study up somehow, some way, somewhere. Okay, so here's the service manual from Vinyl Engine for the 1009 F. The F is very important. Here's the manual. If you've never looked through a record player manual, especially for one that's a fairly advanced record player, I guess I could say, it's an eye-opener in terms of how complex the whole thing really is and how much mechanical trickery is occurring inside here in order for the relatively simple looking operation to take place. There's many little issues. There's the anti-skating thing here. So we're heading down to page 17. I'm just letting you take a look at what's, glance through here. Tons of explanation. Every part has a name. The day use, which you got to get familiar with. Here we are. This is the part we need to look at. Shut off and change cycle. So what I want to do here is look at this manual and then take a look at the record player and see, and well, let's look at the manual. Actually, these pictures should do it, shouldn't they? Let's see if we can't figure out how all this works. It's not quite the same as the one I described. I was describing what you find in a BSR turntable with the two plates. This doesn't exactly have two plates, but here's some pieces right in here that kind of do the same thing. Look, see this black piece right here? That's the kicker that's attached to the platter gear that's coming around, kicking at this mechanism here. And this is the rod that is being pushed in by the tone arm. So this is just a contact point here. Let's read. Shut off and change cycle. The dog, M. Okay, so M. So this little black piece is the dog. The dog M on the turntable gear and the shut-off lever 163. The shut-off lever is this part, which is the part that's going to eventually bump into the gear here and start things rolling. And shut-off lever actuate both the change cycle at the end of the record as well as the shut-off after the last record of a stack. As a record is played, the tone arm moves towards the center of the record, dependent on the pitch of the record groove. This motion carries the shut-off lever, that's this part here, towards the dog by means of the shut-off slide, 189. Okay, so this is the shut-off slide, which is the shut-off lever. Shut-off lever. Okay, so this part is called, whoops, my mouse just went flying. This part's called the lever, the shut-off lever. Okay. The motion carries it towards the, by means of the shut-off slide. The eccentric dog pushes the shut-off lever back at each revolution. So that's what I was calling the kicker. They call it the dog. As long as the tone arm advance is only one record groove. So while the tone arm is playing the main part of the record, this part is moving forward very, very slowly. The shut-off groove with its greater pitch brings the shut-off lever against the dog with greater force. Now that's different than the other style that I was describing. The shut-off groove with its greater pitch, so that's the center of the record where it moves the tone arm rapidly, brings the shut-off lever against the dog with greater force. So this lever is brought on with greater force here. So I guess this lever is being kicked away during normal record playing part, and when it gets to the end, I think it has to do with the shape here, of the end here. And that part of it will kick away, and the other angle, this part, will get caught. And I think that's the trick. And the trick is slow motion gets kicked away, fast motion, this part, this flat part here gets in. Doesn't look like it in this diagram, but I think that's what's happening. The eccentric dog pushes the shut-off lever back at each revolution as long as the tone arm advances only one record groove. Shut-off groove with greater pitch, dog greater force. The shut-off lever then engages and causes the main cam, that's this plastic part here, to be driven by the turntable gear out of its zero position. So I guess they're calling the gap here the zero position. And the kicker, which is hooked up to the wheel, gets pushed. It pushes the wheel and brings the top gear into contact here. There it is right there. They're showing it right there. And away she goes, once around. So now let's look at the diagram here. So you can see that this piece underneath here is in a different position relative to the arm here. So here, ABC. Do they quote ABC here? Big A. As long as the tone arm advances only one groove. Okay, so this is the example of what's happening. One groove advance, This arm is about here and it's getting kicked back. You know, it may even look like the sharp corner here is being kicked off. Maybe that's what's happening. And B, what is B? B is the shut-off groove with this greater pitch. So it's a greater pitch. This is brought in. They're showing this having come around again during the time that this is going around. Right, the groove has dragged this forward and pushed this thing in. So it's going to contact this time. They show it contacting kind of right in this area here. In fact, they sort of show that this never ever engages with the gears here. It's just this kicker that's doing all the work and moving this thing. So how does this not work? Troubleshooting. Tone arm returns to rest immediately after being placed manually on the record. Turntable stops after automatic set down. Tone arm returns to its rest after each record. Turntable stops in manual position. Last record keeps repeating. Too little engagement between the change lever and cam follower lever. Readjust the change lever. So the record on the spindle, okay. Record drops after stop, then start buttons. Record drops after stop. Then start buttons are depressed. I don't know what that is. Records do not drop. Noise during change cycle. No sound. Muting switch remains closed. Motor runs afterwards. Turntable slows down while record drops. Readjust eccentric R1 so that the three supports and the complete. Yikes. Acoustic feedback. That's it. What about record player fails to pick up? Whoa. Not a word on that. You know, there's another section in this manual that also lists misoperation. Let me get right up to the top here. Come down, there was a list. Oh, you know, it's a table of contents. Tone arm set down and lift. Tone arm does not move onto record when drop cycle actuated. Tone arm lowers too quickly. Tone arm misses edge. Tone arm strikes record. So this is the set down. Shut off and change. Tone arm, and they're all on page 13. You know, except for a couple down here, 14. So you know, it's pretty easy to read everything here. Tone arm returns to armrest immediately after being. Tone arm stops after automatic set down of tone arm. Turntable stops. Tone arm returns to rest after each record. Turntable does not turn in manual position. The last record keeps repeating. Record drops after stop, then start buttons are depressed. What? Records do not drop. Noise during. No sound. Motor continues. Turntable slows down. Acoustic feedback. There's no, you know, the closest one is keeps playing the same record. Where was that? Last record keeps repeating. Okay, well, let's go see what it says on page 13 about that. Page 13. 12, 13. Well, last record keeps repeating. Too little engagement between change lever and cam follower lever. 176, 168. 170, well, 168, 160, not on here. Oh, it's down under here. 168. Oh, no. So this is underneath. What does it say? Last record keeps repeating. Too little engagement between 176 and 168. 176. 176. And 168. So right in here, they're suggesting there's something about how these are engaging, and I don't have a, you know, I don't have a memory of. I remember looking at this stuff. I remember the ramp here and stuff. But wow, I can't. Okay, well, I think this is all visible. If we flip the whole record player over, now what are you supposed to do about it? Readjust change lever 176 so that with record on and spindle locked. What does that mean? Spindle locked. There is about a 1/64 inch clearance between the change lever and guide pin of the cam follower lever. With no record loaded, engagement should be about 1/32 to obtain shutoff. 1/32 of an inch. Oh my gosh, what are they talking about here? Change lever 176 so that with the record on and the spindle locked, there is about a 1/64 inch clearance between the change lever and guide pin. Where's the guide pin? Guide pin. Anybody see a guide pin? Any pins noted here? Nothing. There's nothing pointing at any pins. Those are guide pins? Oh boy. I think we need to look at the actual mechanism at this point and try to understand it. I had the distinct feeling that all of this is invisible. I don't know. Let's find out.